Hi, I'm Phil from STEMforge in Australia. I like to call it STEMforge Down Under. So I'm bringing you a project that I've developed. This is the Hyper S3 rocket. I'd like to help you get your projects through the stars with microcontroller. I think it's going to be pretty much beyond them all. I'll give you a bit of my story. I'm an engineering teacher and I've been teaching for 20 plus years, 25 years, and I've been developing electronic circuits almost as long. And this is the new circuit. Being a teacher with engineering, we do lots of fun projects and things with the students. One of those is water rockets. And so it got me thinking, and so I was talking to some students and other teachers about it. What if we could measure the altimeter, like the height of the rocket that it gets to? We can use like a barometric pressure sensor. Or what if we can measure how much it's rotating and adjust fins to compensate? Or could we release the parachute with a timer or something at a certain height, or when it starts falling? So that's where the idea for this little control board came. Now, to improve it, I've chucked on a bunch of sensors, but let me tell you what this is first of all. This is not just a controller, okay? It's got a little Texas Instruments IC there for regulating the voltage, importantly. So you can plug in USB-C, it'll get 5 volts off that, and regulate it to 3.3, but it's a buck boost regulator. So basically that means it can bring the voltage up to 3.3 or bring it down to 3.3, wherever it started at. So that sort of gave me the idea, well, we need to run this on batteries. Why don't we make it have a charging IC? So it's got the Texas Instruments regulator, but it's also got a Texas Instruments charging IC on there. I think it's a BQ25810 if you're interested, if you want to look that up. It's the tiniest little charging IC. It's not cheap either, but it works really well, and you can communicate with it via I2C. It's got default settings and everything, but if you want to change the charge rate and stuff, or if you want to plug in a thermostat or something to measure the temperature, you can change those settings on the board. And so it's got your boot and your reset switches. Don't know if you can hear those. There you go. And but the regulator IC is pretty amazing. Like, it can actually do up to 2 amps, and so you can get power off of this from the whatever battery you have on here. It'll regulate the system power and everything while it's not got a USB connection on it, and that way you can actually power your projects even off the 3.3 volts of the regulator that's here. Now this board here, being the S3 microcontroller, it has a bunch of GPIO. So there's 16 GPIO on this. I've used GPIO 1 to 14 because they're capacitive touch sensing as well. So you've got 14 pins of capacitive touch, 14 pins of ADC as well. All the pins can do PWM, which is pretty cool. It's also got another 2 GPIO on there. I think it's 43 and 44, which are your RXD and your TXD of your UARTs. So you can use that control interface. Also, I've put in a couple of resistors in there for I2C. So you've got the pull-up resistors there already, so you don't have to put on your own pull-up resistors if you want to communicate with I2C. But importantly, the charging IC works off another 2 separate pins for communications, still using I2C, so it's not going to conflict with anything that you connect to it. But the sensors that I mentioned before, they're going to go on the back. That's already developed. It's in a prototyping stage at the moment, getting manufactured overseas. And it's also going to have an SD card holder here that's push-push with a little spring. And so basically it fits in here amazingly just below that aerial. Importantly, the aerial can't have anything behind it for Wi-Fi. And that brings me to another benefit of this board is if you're doing any ground to air sort of communications, you can use 2 of these boards with the ESP Now protocol, which is fully implemented in Arduino language, and essentially you can, like, there's been people out there that have got up to 800 meters, 600 to 800 meters of direct line of sight communication between the ground and the air, which is pretty cool. So you could put these on drones or planes or whatever, but also on rockets. That's the main reason why I developed this. So essentially you'll be able to buy it with or without all the stuff on the back, and in a couple of different versions with the SD card reader alone, or SD card reader with all of the sensors. And so there's different price points there, but also I'm getting it developed with castellated pins on the side. So if you buy it without, you can solder a even thinner one, 17.78 millimeters wide, straight to your own circuit board. So I've developed another project, a Christmas star, that this just plugs into, and it's going to have the SD card holder on the back, and because it's got PSRAM, I've got the model that has 2 megabytes. Is it 2 megabytes of PSRAM, 4 megabytes of flash, and essentially that allows it to do the fast processing for decoding MP3 files and things like that. So it's a pretty powerful board, and having all the sensors on there, the main point of the game was to make sure, because if you can buy all the parts individually, but you're gonna have wires everywhere. You're gonna have intermittent faults, and so it's not going to record data the way it needs to record data and things like that. So I've just put it all on the one board, so we can do some pretty cool rocket science with the Hyper S3 rocket from STEMforge. But I need your help, so I really need to be able to make probably about 3,000 of these to be economical, to get the price down, and that's why I'm going to go through crowdfunding. But if you'd like to be on the list for one of the first people to get the crowdfunding, send me your email address, just privately or whatever, through YouTube or through Facebook, and you should be able to find me on Facebook. My name's Phil Talents. Send me your details, and then I'll put you on the list so that you're one of the first people to know when this becomes available. And to give you an idea, in the production stage at the moment, so I'm testing out panels, getting these manufactured in panels. So I've got a 4-panel almost in the mail now, and just about ready to load up a 12-panel of these with the different options on the same panel. So whatever it is, we'll have different options there to suit everyone. It just matters what price point we can get all of the orders to get them started. So tell your friends about it. It's better than your Arduino itself. It's tiny. It's like 20 by 32 millimeters, including the USB and the aerial at the back. So the board's only 20 millimeters this way, and then with the castellation on it, it's going to be 17.78 millimeters wide, which is pretty phenomenal. I don't know if you can even see that, but there's so many parts on this. There's also going to be another LED on the back, and there's heaps going on with this. But I'll think of 20 things that I didn't tell you when I turn this video off. But yeah, give me your ideas. I love thinking about all the things that could be, and I've got lots of other projects, there on my computer and in my head, and but thinking about like all sorts of other things, of course. But if you want anything else, let me know, and I'll see if I can make it. But obviously, to get them manufactured overseas at an economical price, I really have to order thousands. Like this one cost me over $60 just for I had to buy 5 of them. So because it's all getting soldered by the machinery they have, PCBA, it's called PCB assembly, and it just means that I've got to buy a lot of them. So please help out. Let me know also if you've got any rocket projects and you'd like to see one of these on your rockets, to see how high we can get it, and if we can read all the sensor data off it and everything. I would love to be testing that out first before we manufacture them in bulk. So within the next week or two. Okay, so let me know first and best dressed, and it'll be great. Certainly comment, subscribe, everything. And I'll see you next time. Bye.